Hi again everyone. This is the week 5 video for the workshop class and we're going to cover estimated perspective of curvilinear surfaces based on cylinders and cones. And you can see on these 2 pages when we talk about curvilinear surfaces, we're actually starting from the basic geoform of a cylinder or a cone, and we're going to create some interesting details by using construction principles. You'll be required to do 2 pages for this week. 1 page of 1-point perspective and 1 page of 2-point perspective constructions. And even though these sketches are shown on A4, you will be submitting on A3 and your pages will be full of sketches. So let's have a look at this exercise in some more detail. Let's start off with 1-point perspective, and here I've just pre-drawn some boxes in preparation for turning these into cylinders and cones with some interesting details. Remember, this is a freehand estimated perspective exercise, so there's no vanishing points and there's no horizon lines. But we're still applying the conventions of 1-point perspective, where one of the faces is square to us, all horizontal lines are parallel to each other, all vertical lines are perpendicular to horizon lines and parallel to each other, and all your converging lines appear to be converging to a vanishing point. Because we're drawing cylinders and cones, wherever we have a face that we know is going to be a circle or it's going to be an ellipse, make sure that you proportion those to be squares, whether they're square to our view or whether they're in perspective. So with this one, I'm just going to do something very simple. And let's say I'm going to take out this bottom quarter of this cylinder. So I've found my points. I project this to this point here, and that line should look like it's going to the right vanishing point down the bottom there. I can start to add some line weight. I'm also going to see that inside it's actually the center line. And that's pretty much the feature that I wanted to create, because we're just doing something very simple here, right? So I can come in now and start to hardline my sketch. This is where you can fix up your perspective. Here I'm just going to put some tangent lines to those circles, paying attention that they look like they're converging to the vanishing point down the bottom right here, and then come in and hardline the object. So with this one here, I'm going to do something a little different. I'm just going to create another square, and there's going to be a feature at this point. Now the whole thing is a cylinder, so I'm just going to drop in another circle. That square gives me the diameter of that circle, and of course that's the tangent, so that's still a cylinder, but with 3 circles, 1 through the middle here. I'm going to cross my diagonals again just to find center. I'm going to divide that in half. I'm going to cross the diagonals to find center of that square I just created and divide that horizontally in half. And where I've divided that in half, this point is that point on the middle circle. So I'm just going to join those lines, and this line must look like it's going to the left vanishing point. I'm going to do the same here. So what I've got is half a cylinder at the front, and I'll have a full cylinder on the other half. I can start to come in and hardline. Okay, so what I'd like to see is just you exploring these construction methods. With this one here, again, I'm going to do something a little bit different. Now, I think the feature I'm going to do is a slot. So just above and below that horizontal line, I'm just going to draw a cross. And this is on the face that's square to us, right? So these lines are parallel to all horizontal lines. I'm going to project that back and make sure it looks like it's converging to vanishing point. That's where that part of the slot would be. But of course this edge is sitting in front of that. That's just construction. But it helps communicate what this feature is. I'll also have an inside edge visible. I can hardline that. And of course I would just see that edge. And here's the leading edge. And if that's all I'm going to do, then I can just hardline the rest of my cylinder. This one is set up to be a vertical cylinder, so I'll just cross my diagonals. Similar to what I did here, I'm going to do another plane through the center here. So I'm just going to eye it in. It doesn't have to be in the middle. If it ends up being in the middle, that's fine. Project this line to the right vanishing point. This line to the right vanishing point. So there's another level, right? Another layer. I'm going to drop my ellipse at the top. You can see that top plane is really flat. So my ellipse is going to be really flat. This ellipse will be slightly more open. And this ellipse will be slightly even more open. Here's the tangent. It's going to cheat that in. That's totally fine. Because we want to make sure those vertical lines are vertical. I'm going to divide through the midpoint and have that go to the right vanishing point. That's the front. There's the center. I can go straight up until it hits this edge of that top ellipse and project that through the midpoint, and I can come straight down. If I want to divide through horizontally, I can go straight through that point until it hits this part of the ellipse at the front. I can go straight up. So I'm just cutting out this front corner or segment, which means I would see this part of that ellipse. I'll finish off my detail, right? So I'm just going to hard line. Very flat top ellipse. Here's the bottom of the cylindrical form. And then tangent. Here I'm going to have a cylinder lying on its side, so I know that the two ellipses are going to be straight up and down. The major axes are going to be vertical. This one's going to be flatter. This one obviously is going to be more open, making sure that that major axis is vertical. What I'm going to do here is have a flat feature in the center, but it's still a cylindrical form. So just at the front, because this face is square to us, I'm just going to create another two planes, similar to what I did here, except vertically. I project these lines back to left vanishing point. Right, so there's a square plane. Notice how it's a little bit more open than this one. Project this back. Make sure it looks like it's going to left vanishing point. Square that off. And notice how this plane is even more open than this one, but less open than the back. And that's how it should look. Divide that horizontally. And these lines look like they're going to the left vanishing point. I'm not doing anything different to what we've done previously. Okay, so don't get confused. I'm not doing anything different. I'm still using the same construction method. Drop in my ellipses. This ellipse will look more open than the one on the left. This will look even more open than that one I just drew, but not as open as this one. And the major axes will be straight up and down. Here I'm going to just finish off the body of my cylinder And where I've actually divided horizontally through here, I'm just going to draw a leading edge. I'm drawing it through, and that's what I would see. And when I come into hardline, it'll make sense if you're confused up to this point. Okay. Okay, so let's construct some of these conical forms. I'm just going to quickly go ahead and drop in some ellipses on these square platforms, and then we'll put in some details. You can see here that this line divides this square in half, and it's also going to divide our circle in half. So if I draw a line from here to the point, and from here to the point, that line has cut our cone in half. These lines converge to a vanishing point to the left. If I drew another line that converged to that left vanishing point, where it crosses is actually the height of our ellipse. You can see it here for the base, okay, where it crosses. It actually gives us the height. Our ellipse has to pass those 2 points. So when I have those 2 points, I can use them as a guide and just drop in an ellipse that passes through those 2 points. And it gives us the correct height of the minor axis, or the degree of the ellipse. Then I can just come in and hardline that if that's the feature that I want and I don't want to draw anything else. Right? I would see this part of the ellipse. And if that's all I wanted to draw, then I can pretty much just come in and hardline the rest of my sketch. So we're just wanting to explore construction and just come up with some interesting features. And we always start off with geoforms, cubes, cylinders, and cones. So this is my exposed base of this cone. This is the feature that I want to show. As it hits this ellipse, this point will create an edge. It folds, so I'll be able to see this edge. Hits that bottom part of the ellipse, goes to the point, because that's the nature of its form, right? It's conical. And if that's all I want to show, then I can come in and hardline. Just scribe over the part of the ellipse that I do see, and then finish off that top edge. With this inverted cone, let's say I wanted to add a feature here. Of course, another way of dropping in an ellipse is just to eye it in. My major axis is going to be horizontal. I know the limit of my ellipse has to be these 2 angled lines. And because it's drawn below the horizon line, the degree of the minor axis will be slightly more open than this one, if not the same. And it's slightly more open than that one, and that's good enough. I'm going to draw a slotted feature on here. So these lines give me my vanishing point. It just happens to be on the page. I'm just going to draw a line to vanishing point, measuring off center, line to vanishing point. These 2 points are on the edge of this ellipse. They will go straight down to the point. This is the edge of that ellipse I would see. I'm going to project this back to vanishing point. It's very fine, but all these lines from here, that corner, that point to this point, this should look like it's going to this point, right? And that ellipse, I could see that back part of the ellipse. I've drawn my feature. Just come in with some heavier lines to define the object. Bit of hatch shading to show form, and we're done. I might just add a little bit more of a feature here that looks a little bit boring. I'm just going to estimate my ellipse. I know my major axis is going to be horizontal, so and this is the thing, you know, once you understand fundamentals, you can apply it to just estimated perspective sketching. And I'm going to have a slot feature, let's say about here, and I'm following the curve of that ellipse that I just drew. Smooth transition. It's on the center line, because we cut that in half, that was the center line, and then I'll have the transition to the ellipse, probably about here. Okay, and then define that. So just quickly, this one down here, I'll make it cylindrically based. So let's just quickly drop in some ellipses. Flat ellipse at the top, a little bit more open in the middle, even more open down the bottom. Just to get my guidelines, divide horizontally. I might say that that is visible. I would see this edge of that middle plane ellipse. So that's overhang. Roll this around. Of course, once you've got your ellipses, you can actually even just estimate another ellipse rather than draw all your squares and cross diagonals. Right, I'm looking at the degree of the minor axis, and let's say I want to do this. Go across through the top. This line goes to the right vanishing point, hits that back edge, hits the bottom of that ellipse. Again, right vanishing point, and here's my front edge of that ellipse, back edge of that ellipse. So I've spent quite a bit of time showing you the construction of these features in these cylinders and cones. Essentially, it's the same process in two-point perspective, but you're considering an extra vanishing point. Let's have a look at two-point perspective. Okay, so for two-point perspective, again, I've taken the liberty of just drawing some boxes, going to convert these into cylinders and cones using construction to create some interesting details. Remember, with the convention of two-point, all our verticals are vertical and straight up and down, and our horizontal lines now must converge to a vanishing point, either to the left or to the right, and your lines should look like they're converging to those vanishing points. I'm going to start off with this top left sketch. It's a underside view. I'm going to make it a cylinder. Just like with one-point perspective, if I want to add a feature that's cylindrical, I'm going to create a plane, another surface, and use my construction to find that plane. Cross my diagonals. It's a little bit out of whack, so I'm just going to adjust and tweak it. Divide that horizontally, and at this point I'm going to create a feature. That feature is going to be a smaller cylinder that attaches to the larger cylinder. So I'm going to just visually divide this in quarters and divide that horizontally in quarters to give me this square. So I'm going to have a smaller ellipse in there, And as long as my sketch is accurate, I can still do the same estimation on this face, and I'm hoping that that square is in alignment with this front face square. And I'm hoping that you can see how important what we've been trying to teach you is this wireframe transparent sketching is helpful for constructing things accurately. Just going to drop my ellipses in now. And this one, because this is going to be my smaller cylinder, I'm only going to do that ellipse at the front. I'm also going to do the one inside this square. And now we can construct the body of the cylinder. And then I have my smaller ellipse. Sorry, the ellipse to the smaller cylinder. And that would have a tangent to this front ellipse. So now I'm coming in and just adding some line weight, right? Because I've already constructed the detail. There's my tangent. Remember, this line should look like it's going to the left vanishing point. This line should look like it's going to the left vanishing point. Then I can hardline this this ellipse. Add some line weight, a little bit of hatch shading. And you can double check major axes, 90 degrees to minor axes, which is the center line. Major axes, major axes. These two views are also going to be cylinders. Just to save time for the video, I'm just going to go ahead and quickly construct those details. With this view, I'm going to add some features to this cylinder. So just like what I did up here, I'm just going to create some planes, surfaces, or sections where I know that's going to have a form change. You can see how important it is to construct really lightly, otherwise it can be really quite confusing. So I'm going to have maybe an extra 2 sections through here. Vertical lines, vertical, horizontal lines should look like they're all going to that right vanishing point, nice and light. Okay, but you can see it's all in perspective and all converging to the left and right vanishing points. Just going to drop my ellipses in. I'm going to have a flat section through here. So I'm just dividing in half. This line should look like it's going to the left vanishing point. You know, if in doubt, just keep it nice and light until it's accurate. I'll just do my tangents to my cylinder at the back here first. This line should look like it's going to the left vanishing point. Okay, then I can drop in this part of the curve and the back. Smooth transition to the body of the cylinder. This I can just hardline if I'm comfortable with that. I might also have, let's say, instead of this being a cylinder, sort of like a little arm that pops out from there. I'm measuring this off this vertical center line. And I'm taking this part of that ellipse. So I'll actually see this edge. I can project, I'm turning my page, but I'm going to project back to vanishing point. Here's my original center line. And this is actually where it joins up on that flat surface. And these lines should look like they're going to the left vanishing point, all in perspective. This comes straight down. It comes straight down until it hits this part of the ellipse here. And then, if it's accurate, this line should look like it's going to the left vanishing point. Of course, then this curves. I'm taking this ellipse. So we're really getting into a little bit more complexity here. Follow that ellipse around until I see it, and then hardline that. This is an edge, this is an edge, and that line is not going to be hardline because it's all the same surface. Pretty much finished with the sketch, just this line. Little bit of form, description with some hatch shading. I guess what we could also do, because we're learning about center lines and contour lines, I could drop in this line here to communicate center line, right? It comes up, across, up again, and over the top, and down, across, and below. Here's a center line for this, where it's just straight through, and then this goes up and over the top. And you can see that mid-vertical line, when I join that up, which is true center, this is constructed center line. So now you can see how it relates to the center line contour lines that we're doing for the speed form exercises. So I've just quickly turned this into a cylinder. Remember, if you understand ellipses, and the closer that surface is to the horizon line, the flatter that minor axis is. Further away from the horizon line, the more open it is. Then you can just also estimate. So in my rotation, I'm just looking at how open that minor axis might be. I'm wary about how open this one is. So I might just drop in that ellipse, drop in another ellipse a little bit more open. Now, where this divides in half through the midpoint, and here where it divides in half in the midpoint, they should be directly aligned. So that's the center line vertically, front and back. And here I'm just going to decide on what features I want. So I might say it's flat, vertically flat here to there. And make sure that these lines go to your right vanishing point. Maybe I do see this, that surface of that, maybe I continue this line straight down here. And I see, this is an overhang. So I'm tracing off that part of the ellipse. I will see that far side vertical edge, and it cuts through. Then I'll have my body that turns away. I'll see the top of this surface, which of course is the ellipse, and it's flatter than that. And then just do my vertical lines for the body. A little bit of hatch shading. If I wanted to show center line as part of the construction, I could do this, come straight down. I'm being aware of where the vanishing point is. That will come straight down. It steps back in, we have the construction, and that's actually the center line. So it goes up, underneath, across, up, across, up, across. So here you can see I've already dropped in some ellipses. These are going to be cones. And we've covered quite a bit of construction, so I'm just going to create some features on these views. Okay, ellipse, make sure that major axis is 90 degrees to that center line. If I want to have a feature, okay, let's say there's my midpoint. This goes to left vanishing point, left vanishing point. That's where it meets up. Take that part of the ellipse. This should be going straight through to the point, to there, straight line. On the far side, straight line through this point to there. And the fact that we can see through here gives us an understanding of what is this feature. But this is still conical. See at this point, oops. And this is pretty much the sketch. The construction line or center line would be there. We would see that. It drops back behind that part of the curve and then comes back into view here. So that's the top vertical center. You'll remember from our 1-point perspective sketch of a cylinder, of a cone like this, I divided it in half just by following my construction lines up. So if I was to cut this cone in half, it would be along this line. Let's say I eyeball an ellipse. There it is, major axes. Okay, the higher I go up, the smaller the degree of that ellipse should be. I might have a feature where this is like a stepped out leg. I'm measuring off the center line. I will see this part of that ellipse at the base. It may go straight up to this ellipse. That's actually an overhang. I'm just making it up, of course, as I'm going along, right? I would see this edge. This goes straight up and on that center. Now, from this point, it should go all the way up to that point. So this is a little bit incorrect because it's gone too far. That's fine. And then this is where it meets up with the base, which is that original ellipse, and it goes straight up to this point, as does this side. And we can just see that far side horizontal, and that should also go to this point. We would see just that part of it. You can see how accurate that is just by following the conventions of perspective and construction. So it doesn't all have to be complex. I'm just showing you where we can take this, and it's certainly going to help you with your freehand perspective sketching, especially when it comes to drawing quite complicated objects and structures, especially in product design. Okay, so there's a cone. We might keep this one a little bit simple. So if this is my elliptical base, but I'm going to chop a wedge at 45 degrees on that quadrant, 45 degrees on this quadrant. I take that point where it hits that ellipse and goes straight to this point, if that's the feature that I want. Same again to this point. This is the bottom of the cone. I can come in and hardline my ellipse. Okay. It's going to modify this. I'm mimicking this line across, mimicking this line across. I'm going to estimate this ellipse through that cone. It'll be more open, which means I'll have this curve of that part of the ellipse. This edge will be visible. That fold line, leading edge, base of the cone, or the bottom line of the cone, and top. This will be slightly angled downwards. And this part of the cone would be turning away from light. Okay, so just manipulating surface by basic geometry in construction to add details to our geoforms. So this is the last exercise for this Sketching Portfolio 1, and the requirement for these 2 pages, which is estimated curvilinear constructions, 1-point perspective of cylinders and cones, A3 of course, freehand sketched, showing interesting details with your understanding of construction. You'll do that as well for 2-point perspective, again A3 page full of sketches, freehand, lightly constructed with a little bit of hatch shading and some constructed details using your understanding of construction. Okay, so good luck with that, guys. I'll look forward to seeing this on Thursday to give you some feedback.